The picture shows a sinkhole. Right here we see this big sinkhole. Which of these most likely caused the sinkhole to form? So the question is about how do sinkholes form. And sinkholes form from rock underneath them, the ground underneath them, dissolving and disappearing. And that's caused by water reacting with the very basic rock limestone. So the little bit of acidity in the water dissolves the limestone and you end up with underground caves and caverns. So our best answer here is A, the collapse of the roof of a limestone cave. Limestone chips dissolve after they are placed into a beaker of dilute acid. Which geologic process is this most similar to? So when you take a rock that's like a carbonate, that's a basic rock like limestone, and you add a acid like vinegar or even acid rain to it, you'll see a chemical reaction, and that chemical reaction is going to be the dissolving of the carbonate on the limestone. And what that leads to is really beautiful caves and caverns and sinkholes. And this is a type of chemical weathering. So the answer here is H, weathering. All of the following may be found in these caves, except groundwater. Well, you will find water in these caves. That's what created the cave. Remember, through chemical weathering and the dissolving the limestone. Mineral deposits, you'll absolutely find those. You'll find those in the form of stalactites and stalagmites. Photosynthetic organisms. Remember, photosynthetic are organisms that make their own food. But what do photosynthetic organisms like this plant need? The first and most important thing they need is sunlight, which you're not going to find in this natural cave. So the answer is all the following except C, photosynthetic organisms. Okay, I'm going to skip reading this very, very wordy question. But the question is basically about barrier islands like the Outer Banks. Now, these Outer Banks that we have right near us here in Virginia Beach are a movable island. This island is constantly moving westward, and when it moves westward, eventually it hits land and then becomes a really nice beach on the land. But the reason it moves is every time we get a big water surge or wind, the waves will come up on this side of the island, and it'll wash the island over to the other side of the island. So they are a movable set of islands. That's why they're not permanent. And the reason for that is C. The wind and the waves are constantly redistributing the land. C. So which of these pieces of basalt rock has probably been in the river the longest? We got a square piece here, and we got a funky irregular shaped piece here. We got a very kind of rounded, smooth piece for C, and then we got another little bit larger irregular piece right here. So the longer a rock is in a river, the more that it's going to be weathered and eroded by the running water and also from the collisions as it rolls through the river and bumps into other rocks. The longer it's in the river, the more polished and the more smooth it's going to become. So the rock that's probably been in the river the longest, your best guess would be C, the smoothest one. So C. Okay. Which of the following most likely results in the formation of a fossil? So how's a fossil made? So we got a couple choices over here. We have a dead fish, and that dead fish could be just eaten away. It could float at the top and decompose. As it's decomposing, it might be eaten away until there's just nothing but a little bit of its bones left. Or this dead fish could get buried. And if this fish does get buried while it's still intact, inside this new sedimentary rock that's formed, you'll find a fish skeleton. So the best answer here, a Mesozoic clam lies exposed on the surface of the seafloor. It's probably not going to make a fossil. All right. A Mesozoic clam is washed up onto the beach. Also, probably not going to make a fossil. A clam is eaten by a large predatory fish. Also not going to make a good fossil. But what if a Mesozoic clam is buried by a mudslide? And as it's trapped in that mud lithifies and turns to rock, and then you have a fossil. So the answer is D. So which of the following best explains the rolling topography of the Valley and Ridge province in Virginia? So if you've ever been out to the western part of Virginia, you'll see these like beautiful mountains. Like you can see them right along here. You see this big ridge, and then inside that ridge you're going to see this very flat valley, and then the next you're going to see another large ridge. And if you look at it from a profile from above, you can also see some ridges, and then you see some clouds right here. It's kind of hide in the valley, and then you'll see another ridge, and then some clouds in the valley, and then another ridge. So why do we have some rocks that stay up really high and some rocks in some parts that are very low? And that's just because we have different rocks. We have, in general here, we've got some sandstone rock that doesn't weather as quickly as what's down here, the limestone rock. The limestone rock gets dissolved away by the rain and carried away by the rivers, but the sandstone rock is much more resistant and stays taller longer. So the reason we have this topography, folding and differential erosion. The differential erosion comes from sandstone and limestone eroding differently, and the folding is when the continents collided many millions of years ago and they pushed the rocks upward and bent them and folded them. So our best answer here is letter A, folding and differential erosion. So why does erosion not occur on the moon? Now, if you remember, our major causes of erosion here are running water, rain, we've got wind, and those are the major things, and you don't have either of those on the moon. So what's our best choice here? The rock surface of the moon is too hard? No, that's not it. The moon's got about the same rocks we do, it's just a little difference in the amount of iron. The moon doesn't have as much. There is no animal life. Well, that is a true statement. There is no animal life on the moon, but that's not the reason that we don't have erosion. Not the main reason, anyway. There is no wind or rain, so that's true. There is no wind, there is no rain, there's no atmosphere on the moon. So, and the wind and the rain is what causes erosion. So our best answer is C. There is no wind or rain. Alright, which of these best shows wind deposited sediments? Alright, so sediments are little pieces of broken down rock, and so only the smallest pieces can be picked up and carried by the wind. So this structure right here and this structure right here, A and C, probably were created by the wind, but they weren't deposited by the wind. So they may have been created by, these are usually in the desert, but very possibly by wind picking up the sand and the sand blasting these little rocks and breaking them down. So A and C could be made by the wind, but they are not deposited by the wind. Letter D, this might be tough for you to see, but what they're trying to show you here is a gigantic canyon, and this canyon was carved out by water. So the water was causing the erosion and the weathering in letter D here. So our best answer of wind deposited sediments are making sand dunes. So the wind can make sand dunes. It can pick the sand up and it can carry the sand. The stronger the gust of wind, the more and the heavier the sand that it can carry. And a sand dune is letter B. So letter B is the correct answer. Alright, the canyon shown in the picture was most likely formed by, so what forms a canyon? If you notice, the rocks on the top are very flat, and it looks like something just dug out this big S-shaped groove right here. So what could have done that? A volcano? Not likely. High winds? Also very unlikely. An earthquake? I know it kind of gives you that impression. It looks like the earth was pulled apart, but it wasn't that dramatic. These canyons, like this canyon right here, were formed over millions and millions of years as a river slowly worked its way through. And as the river gets faster and bigger, the erosion exponentially increases as well. And you can see this really cool picture of the Colorado River carving out the Grand Canyon. So since rivers cause canyons, the best answer here is J, running water. Okay, which of these substances plays the most important part in chemical weathering? Alright, so let's first take a look at these two pictures to understand what chemical weathering means. In both of these pictures, we have water breaking down a rock. In the picture in the bottom right, what we have is we have waves crashing into the land and physically breaking the rock down. It's not a chemical reaction, so this one right here is called mechanical weathering. On the other hand, over here, we have water. working its way through little cracks in the ground and dissolving the very basic limestone rock. So as this limestone rock gets chemically dissolved, that's chemical weathering. And our most important part in chemical weathering is usually going to be water, G, a slightly acidic water, like acid rain, G. Compared to the Rocky Mountains, the Appalachian Mountains are are the Appalachian Mountains older, less eroded, higher, or thicker? All right, let's look at a picture of both. So here's your Rocky Mountains on the top picture. You can see these Rocky Mountains are very grand, they're very high, they're very tall. And on our bottom picture here, we see the Appalachian Mountains are much less pronounced, a little bit flatter. You can see a lot more forest developed over them. So our Appalachian Mountains are more eroded, not less eroded. They're lower, not higher. And thicker is just not a great word to describe the mountain range here, but they are a little more spread out. Alright, so the best answer here is A. The Appalachian Mountains are much older than the Rocky Mountains. So caves are found in Virginia's Valley and Ridge Province because the area is underlain by, so what was that rock that's always being dissolved under the ground, which develops caves and caverns and sinkholes, and it's called karst topography? The answer is limestone. Limestone is the rock that's being dissolved away, and it's being chemically eroded by the slightly more acidic water. Alright, which of the following is an example of chemical weathering? So splits in a rock due to tree roots. So sometimes the roots of plants can go into a rock and actually mechanically or physically break them up, but that's not a chemical reaction. Pulverized rock resulting from a landslide. So if you have all kinds of rocks like tumbling down the side of a mountain from a landslide and hitting each other and breaking up, that's not a chemical reaction, that's still mechanical weathering. So a rock broken into chunks after being carried in a rapidly flowing water, like a river, that's also not a chemical change, that's a physical or mechanical change. So the dissolving of limestone by acid rain, yes, that is a chemical reaction. So the answer is D. So far we've been talking about chemical weathering a lot, but this question's the opposite. So when you break down a rock or a mineral into smaller particles without changing its actual chemical composition, this is called, like for example, this rock right here that's been split in half was split over millions of years as a little bit of water creeped into it and froze, and then it pushed apart, and then some water went in a little farther and froze and pushed apart. It's called frost wedging, and that is an example of mechanical weathering. So when you break down a rock without changing its chemical composition, the answer is H, mechanical weathering. Alright, so which of the following processes will change a sedimentary rock into an igneous rock? This is kind of a strange question. So how do you get a sedimentary rock back to an igneous rock? And remember, igneous rocks are your original rocks that form from the cooling of magma and lava. So in order to make a sedimentary rock that was formed in this fashion, in order to make a sedimentary rock an igneous rock, you got to melt it. And so our best answer here is melting and crystallization. So A, melting and crystallization. Alright, number 17, we see an ocean right here on the side of a mountain range. And what we're getting this illustration, we're getting some weathering occurring to the rocks at the top of the mountain, and then they tumble down and they're eroded away, and then they're deposited or dropped off here along the beach. So which kind of rock is made by weathering, erosion, deposition? There's your sedimentation, and then don't forget the compaction of the material, and then the cementation of the minerals will glue these rocks together, then they'll be recrystallized, and what we've got now is a G, a sedimentary rock. G, a sedimentary rock. Heat and pressure can transform igneous rock into metamorphic rock. So what are our processes that can transform an igneous rock, a lava and magma rock, into a sedimentary rock? So what we're really looking for is these steps where we have weathering and erosion to break the rock down and carry it to a new location as sediments. The sediments get smushed together through compaction, and eventually they get compacted more and more, and they get glued together and cemented together. And so our best answer here of how to make a sedimentary rock, heat and pressure, no, that's metamorphic. Rifting and subduction, those are more terms associated with plate tectonics than rock building. Erosion and sedimentation, absolutely. H is the best answer here for number 18. Alright, the picture in the question shows a limestone building block. Which observation best shows that the limestone rock you see right here was formed from the ocean? So if you look at this rock, we see little starfish, little brachiopods, little tiny, lots of shelled fish, lots of ocean marine animals. And you can kind of see a more realistic picture instead of a drawing here of what a rock that's found in the bottom of the ocean will often look like. Right? So the best way that we can tell is not the thickness of the rock layer, and also be careful of this one. This is the tricky one that people pick. It's not the number of fossils, it's the type of the fossils. So if you see ocean animals in your rock, that means this rock was probably formed from ocean sediments. So the answer here is H, the type of fossils. Alright, number 20, this is a good question. So which type of rock are fossils most likely to be found? So if you know the difference between an igneous rock, a sedimentary rock, and a metamorphic rock, this should be an easy question. So since igneous rocks are formed from the cooling of lava for the igneous extrusive, or magma from the igneous intrusive, you're not going to have any fossils. You're not going to have an animal that was able to be preserved and preserved for millions and millions of years. If it was in lava or magma, it would have been destroyed. It's probably not going to find one in a metamorphic rock, because remember, metamorphic rocks were subjected to such extreme heat and pressure that an animal skeleton would have been deformed and destroyed. All right? But sedimentary rocks are formed from little sediments that get piled up and compacted and re-glued together, and sometimes you'll find an animal that died in those sediments and was buried and was turned to stone. So fossils are found in sedimentary rocks. Sinkholes associated with the natural processes are a characteristic of what type of bedrock? I hope by now that you've caught on that sinkholes and caves and caverns and all this type of bad things that happen, a lot of it in Florida, is a result of limestone being eroded away underneath the ground from underground water. It's not granite, the igneous rock granite, or the igneous rock basalt, or the metamorphic rock gneiss. So it's limestone that gets chemically eroded and results in all these terrible things happen. Limestone is a valuable resource in Virginia because limestone can be processed to make what? So if you ground up the limestone, you add some water to it, it does not make plastic. It definitely does not make steel. I hope you wouldn't pick wood. We know that comes from trees. And our best answer here is H, concrete. That's what limestone is used for, building materials and construction. In karst regions, caves are carved by the flow of water through limestone bedrock. How do these stalagmites and stalactites in the caves develop? Remember, stalactites are coming from the ceiling. They got a C for ceiling in them, and they're working their way downward. Stalagmites are, I wish I remember stalagmites. They might reach the ceiling someday because they're trying to go higher, stalagmites. And how are they made, though? They are just mineral deposits. As the water is eroding the cave and making the cave bigger and bigger, sometimes the water drips, and it has some very mineralized water, and that drip, that evaporates away, and it leaves the minerals behind, and they just keep getting a little bigger and a little bigger every day. So A, they are carbonate deposits formed by dripping water in air-filled cavities.